Here we have calculus 2 problem on infinite series. Okay, let's go to the question. Use the sequence of partial sums to determine whether the series converges or diverges. Okay, here we have an infinite series and we have to check whether this series converges or diverges using the sequence of partial sums. So for that, first I have to write the nth term of the given infinite series. That is nothing but the stuff what we have here, -1 to the nth power. So if I plug in n equals to 1, I'll be getting the first term of the series. If I plug in n equals to 2, I'll be getting the second term of the series. Okay, now let me find the first partial sum, that is S1. First partial sum means like I have to get the sum of first one term. So first sum of first one term is nothing but the first term of the series. So to get the first term of the series, I have to plug in n equals to 1 over here. When I plug in n equals to 1 into the first term, nth term, I'm getting -1 to the first part, which is equal to -1. So the sum of first one term is just -1. That is the first partial sum. Okay, now let me get the second partial sum. The second partial sum is nothing but the sum of the first term and the second term. That is the sum of first two terms. Okay, to get the first term, I have to plug in n equals to 1 into the nth term. Then I'm getting a -1 to the first part. Positive. To get the second term, I have to plug in n equals to 2 into the nth term. Then I'm getting -1 to the second part. So -1 to the first part is just -1, positive. So when I evaluate this -1 the whole square, I'm just getting 1. Then I'm getting 0. So the second partial sum is 0. That is the sum of the first two terms of the given series is 0. Okay, now let me find the third partial sum, that is S3. Then I have to get so the sum of first three terms. Already I know the two terms over here, -1. +1, positive. So now I have to write the third sum because sum of we have to get sum of first three terms. This is the first term, this is the second term, already we got it. So now to get the third term, what I have to do is I have to plug in n equals to 3 into the nth term of the series. So then I'm getting -1 to the third part. So then I'm getting -1, +1. So when I evaluate this one, -1 to the third part is just -1. -1 times positive will become -1. So this -1 +1 will become 0. So I'm getting -1. Okay, now let me find the fourth partial sum. That is the sum of first four terms of the given series. So already we know the first three terms, that is -1, +1, -1. So to get the fourth term, I have to plug in n equals to 4 over here. Then I'm getting -1 to the fourth part. Then I'm getting -1, +1, -1. So when I evaluate this one, I'm just getting 1. So when I evaluate the sum of these four terms, I'm getting 0. So like, okay, I think this is enough. I got the first partial sum, second partial sum, third partial sum, and fourth partial sum. Okay, now what I'm going to do is I'm going to form a sequence with the partial sums what I got over here. So that is like S1, S2, S3, S4, and it will keep going. Okay, so now I can form a sequence with the partial sums S1, S2, S3, S4. Okay, now I have to check whether this sequence converges to a finite value or this sequence diverges. So if this sequence converges to a finite value, then we can say the given infinite series converges, and the given infinite series converges to a value to which the sequence over here converges. Or if the sequence formed by the partial sums diverges, then we can say the given infinite series will diverge. So okay, now we have to identify whether the sequence formed by the partial sums converges to a finite value or it diverges. So how do we have to find that? So for that, let's plug in the values of S1, S2, S3, S4. The first term of the sequence is given by S1. Its value is -1, and the second term of the sequence is given by S2. Its values, so 0. Again, we get -1. Again, we get 0. Anyways, like when I look at the terms, the pattern of the sequence over here, we have -1, 0, -1, 0. So we have only two values, -1 and 0 alternatively. So definitely this sequence will not converge to a finite value because we have only two terms, alternative -1 and 0. So even if I find the fifth term of the sequence S5, it will become -1. The sixth term will be 0. Seventh term will be -1. So it does not convert, it does not converge to a finite value. So the sequence formed by the partial sums of the given series diverges. Since this sequence diverges, so the given infinite series diverges.